From time to time, I'm going to try making a couple of these videos for the various chapters we come through. And what I want to do is give some worked out examples of some of the problems in the back of the text, usually some of the more difficult or advanced ones, to supplement what we do in the classroom. And for this one, it's going to come from chapter 1, it's problem 70. Put that down over here someplace. And it's one of these, fairly involved conversion factor type problems. So what I'd like you to do is first take a look at the thing, read it over carefully, and then we'll start tackling it. So here you go. Now, the typical response for students at a lesser university and with a lesser instructor is to read that over and say, "Ooh, I can't do that. That's too hard. Oh, dear roommate, pour me another," and go on from there. This, however, is Georgia Southern. This is my class. We don't operate that way. For you guys, the proper response is to read it over and go, "Ooh. All right, you mother, you're going to get solved," and start working on it here. And that's exactly what we're going to do. And so I'm going to start writing down some things in here, and I'll probably write things right directly in front of me in a few moments, and that's okay because it's not me, it's all the problem solving that we're trying to go after here. But as I've talked about in class many times, the most important thing when you read this problem over, and it's got lots of stuff in it, I admit, Part A, Part B, introductory section, all that, is in Part A particularly, what are they after? And what they're after is number of dollars per liter. So that's the first thing I'm going to write down, question mark, number of dollars, and I'm using dollar sign as a unit, in 1 liter. Okay, so we're going to fill this thing up with conversion factor type stuff, and when it's all said and done, at the end, we're going to have a number. The number will have units of dollars. That number will express the number of dollars it takes for desalinated water, taking something like ocean water, taking the salt out and making it drinkable, to have 1 liter. Now, there's lots of other information in this particular problem, and I'm going to start writing down some of it out here. And I do have it kind of written down for myself kind of as a cheat sheet over here, so as I keep looking back and forth or something and write the things down. I'm going to start reading through the problem, pulling out of it all of the various pieces, okay, because there are some conversion factors in there and other bits of information we're going to need to make note of. The most important thing in this one is this kind of strange volume unit, 1 acre-foot. It's a very large volume. We don't use it in chemistry often just because it's so big. We never encounter volumes like that. But it is one of these English type unit volumes, and I want you to realize that using the knowledge you've been gaining in class or something, it's a volume. Volumes are 3 length units, length, width, height, or areas times height. And that's what an acre-foot is. And in fact, they come right out and tell you the definition of an acre-foot is, and there it is, 4,840 square yards in 1 foot depth. There is the area and the height. Square yards area, and there's the height. It's this strange mix of units, square yards and 1 foot. But we'll take care of that in just a moment. But I want you to realize it fits all the definition of volume type units. And in fact, ultimately our strategy is simply to turn that silly old volume unit into liters, which is another classic metric volume unit that we're going to make use of. The other critical conversion factor that they give us in this one is 1 acre-foot of desalinated water costs $1,950. And yes, I'm putting the dollar sign at the end. I'm using it as a classic unit. That is a conversion factor the problem hands us right there on a silver platter. Now, there are a couple of others that we're going to need to make note of from our database in the back of our minds. 3 feet is 1 yard. Okay, classic English type unit. And the other one that's really important for our purposes is the definition of a liter. Remember, it is also known as a cubic decimeter. 3 length units multiplied together. And we're going to make use of that because you can kind of see where this is going to go. There's our length units collection. It's English units, so we're going to take care of all that. And we're going to turn them into decimeters, which means we've got liters. And so I'm going to outline quickly the strategy I want to follow for this. We are going to take our acre-foot volume unit and we're going to get our little fingers on cubic feet. Now, once we have cubic feet, it'll be fairly simple to get to cubic inches. Cubic inches gets us to centimeters. There we are in the metric system finally, because this is a well-known, I'll even write that down. 1 inch is 2.54 centimeters, one of those common ones we make use of here. Once we've got centimeters, we're just one little step away from the cubic decimeters, which means, yes, we have arrived at liters. So we're going to turn 1 acre foot into liters. Basically, we're going to get ourselves the conversion factor for, how many liters is in an acre foot. It'll be a large number. It's a big volume, but that's what we're going to do. And so what we're going to do first is get our little fingers on cubic feet. We have square yards times feet. So really, all we need to do is turn those square yards into square feet. Multiply by the 1 foot here, the depth of the acre foot, and we'll get our fingers on cubic feet. Away we go. We have 4,840 yards square in 1 acre. Yards, I like yards just fine, but screw them. Die, pig, dog, die. We divide them out of there. We're going to turn them into feet. Yes, indeed, there are 3 feet in 1 yard. Oh my, that's a square unit. We know what to do about that. Yes, we square the whole conversion factor. So when it comes time to handy-dandy magic calculator, 4,840 times 3 squared. Oh, yes. And that will get us a number in units of square feet. And in fact, the number is, what was that number again? There you are, 43,560. 43,560. And yes, I calculated that earlier. I'm not popping that one out quite that readily. And then we're told the acre foot is this square yards or that square feet times 1 foot, meaning we have 43,560 cubic feet, pretty 3, in 1 acre foot. There we go. We're now in our cubic feet units. Now it's off to the races. So here we go again. 43,560 cubic feet. Once again, I love feet, but the feet go and I turn them into inches. There are 12 inches in 1 foot. Cubic units, oh my, we can take care of that. Inches, that's nice, but we don't want them. We want centimeters at the moment. 1 inch is 2.54 centimeters. Oh my, cubic units. Cube the whole thing. Once we got our little fingers on centimeters, boy, we are close now. Centimeters to decimeters. One of those metric conversions. Remember, they're only a factor of 10 apart. Centimeter is the smaller one. It takes 10 of those to be one of those. Oh my, I have to cube my conversion factor again. So now we have our little fingers on cubic decimeters. And I am going to add one other one in here, though it mathematically doesn't make much difference. Decimeters to liters. 1 liter is 1 cubic decimeter. Notice something. I'm not cubing the entire conversion factor. Now it's cube unit to regular unit. So the cube can be inside here. Now, even if I put it outside, frankly, it's 1 over 1. It's not going to make any difference mathematically, but that's okay. I do it for completeness. And now I start doing my magic calculator dance over all that. And I hope I come out with, there it is, 1.23 times 10 to the 6th. And the only unit left standing, cubic feet are gone, cubic inches gone, cubic centimeters gone, cubic decimeters gone, is liters. Okay? So there's our conversion factor. 1 acre foot of water equals 1.23 times 10 to the 6th liters. Now that we have that nailed down, we could turn the liters into we could turn that 1 liter into acre feet and the acre feet into dollars and answer this question. And that's what we're going to do now. The question ultimately is, of course, dollars for 1 liter. So there we go. 1 liter. Liters, I love you, but die, pig, dog, die. It's back to the acre foot. We're told 1 acre foot is 1.23 times 10 to the 6 liters. And then acre feet. Go away, acre feet. You are now turned into, yes, dollars. $1,950 is 1 acre foot. And if I now punch that out on my calculator, I come out with another number. It's actually quite a small number, 0.00159. 0.00159 dollars, or 0.159 cents for 1 liter. Relatively cheap, less than a penny to desalinate a liter of water by whatever system this problem is making use of. So there it is. We analyzed what we wanted, read the rest of the problem, and used some of our knowledge about other conversion factors in the definition of liter. Strategized that basically it's a volume to, English volume to metric volume type conversion. We've seen plenty of those. Outlined the strategy and then executed it. And there's our answer. There is the answer to part A. Part B asks us how much is it going to cost to desalinate enough water for 1 year in a household. That is pretty quickly answered. I am going to apply the magic eraser to part of my board here, and we'll go ahead and tackle that one next. All right, now part B simply wants how much is it going to cost, number of dollars, in 1 day. For how much does it cost to have enough desalinated water to supply a household for 1 day? That's part B. Now, in here, they give us one other conversion factor we didn't need for part A, but we're going to make use of it now, and that is 1 acre foot of water is enough generally for 2 households, 2 homes in 1 year. So in other words, 1 house is going to consume a half of an acre foot in a year. Okay? So 0.5 acre foot per year for 1 house. Acre feet we know how to turn into dollars. I'm going to go ahead and do that now. Acre feet here. 1 acre foot is $1,950. Now, the other one we need to get rid of is the years. Okay, and the years is going to get turned into day. That one's a pretty obvious conversion factor. One critical thing, there it is, years. We want to get rid of them. We say die, pig, dog, die, which means we divide it out. It's on the denominator already. Oh my gosh, that means years appear here at the top. And we turn them into days. 1 day, 1 year is 365 days. We punch that out on our calculator. And 2.67 is what I came out with. And my units are, acre feet are gone, years are gone, dollars per day. A little under $3 a day to supply 1 house with desalinated water, if that is their only water source. Not too bad. And so there's part B, which is actually a lot easier to do than part A. Once you get through all the hassle of part A, part B is pretty simple. There it is, a worked out example of problem 70 in chapter 1 of our text, employing all the little business that we've talked about in class, reading the problem over, identifying the unit of the answer, writing down and extracting from the problem other conversion factors, making use of some of our knowledge of basic conversion factors like the definition of volumes, the definition of liter, strategizing a little bit, and out it came. Relatively straightforward once you start thinking about it. Yes, you should be able to do this on your own, so get practicing.